everybody, Tuesday night. Welcome to Unmasked Weekly. I want to let you know that this is not the Twilight Zone. This is actually me. I've been gone for a long time, so don't adjust your set. Don't check your calendar. We are live, coming here from Stillwater, Oklahoma, the world headquarters of Kicker Car Audio. Before we get started, I want to give a shout out to those 4 astronauts from Crew 9 that landed safely today after 286 days in space. I get crazy when I get tied up in the house for 12 hours at a time. I can't imagine being in a space station for 286 days. So secondly, we've got a great crew as always. Got Ernie back there behind me. We've got Colin, and of course, running the console, we have JW. So those guys will be running, making sure I'm keeping on track. We've got a couple good guests coming up today. But if you guys happen to be new, if this is your first time watching the show, and I know there might be a few of you out there, we always like to give away something at every show. So we're going to do a drawing. To register, you're going to sign into Kicker/UM Weekly. You're going to register up until 8 o'clock tonight when we cut it off. All the winners are going to get the t-shirts and the koozies. The third place winner is going to get the EB400s, which are the wireless Bluetooth earbuds. The second prize is going to get the TW2s. Those are in-ear wireless earbuds, and those things are awesome. They're great. I use them all the time on the airplanes and riding a bike. And the grand prize winner is going to get the BF100. That's the little Bullfrog Bluetooth speaker. It is completely waterproof. And that is going to be your grand prize winner for the night. So make sure you stay and tune in for that. As always, if you like what you see, hit like and subscribe. We do this with your help and support. We don't get paid for it, but we like doing this. We don't like having a real job, so this is a whole lot more fun. So thank you guys for tuning in. We're going to take a quick break. Then we're going to talk, of course, LX amplifiers, and I got a couple special guests we're going to bring on to help me do some testing. So we'll see you here right after this commercial.
It's been a long road since the original Kicker christened that first pickup truck. It kicked off a car audio renaissance, and upgrading your music in a vehicle was a requirement. America's music machines became living loud over your passion, your emotion, your existence. Outdoors or on the open road, your sound is Kicker.
More than 50 years, Kicker has been rocking the planet on anything that moves. Kicker, the legacy continues.
Sexy touch is enough to make me and my Chevy blush. So long, take it all off of that highway. Turn me on, I'll let you drive, baby. You can take it fast as you want to. Girl, little dirty looks damn good on you. Start me up, Stones on the radio. Girl, I love it when you let go. Long way, short way, in the wrong way. So get off on some 4x4 play.
Music is my passion, my livelihood, and it's in my DNA. My pals at Kicker Marine Audio gave me a chance to take the music, what I love and listen to, at home, on stage, and in the car, onto the water. Hi, this is Jason Bonham, and I want to say a big thank you to my friends at Kicker Audio for inspiring the songs and the stories behind the music that inspires America. Go overboard! This is your time.
Rolling with my two guests over here. I got to give a shout out to a lot of you guys that we see quite often. Ashley, thank you for the hat. If you notice I'm not wearing the sweatshirt, that's because it's way too warm in this studio. Ernie likes it hot in here, so couldn't wear that because I didn't want to be sweating all over everything. But of course, we had Bobby Burkett out there. We've got Ashley, Larry, we've got, of course, Cassie. I saw her name up there a little bit ago. And, of course, Stu's Custom Shop. Got a lot of good people out there that tune in quite often. So if you guys have any questions about Kicker Car Audio, these guys can obviously jump in and probably answer a lot of your questions. But your biggest two questions right now are probably who is that and who is that? So we're going to introduce Joe Hobart. Joe, tell us, and for those of you that haven't seen you on the show before, this is what, your third time, fourth time?
I think it's fourth, yeah.
All right, well, if you haven't seen Joe, Joe's going to tell you a little bit about himself, and we're going to get rolling.
Yeah, well, I'm the Director of Electrical Engineering here at Stillwater Designs. Been here for 19 years now, if John can believe that at this point.
I remember when you came.
Yeah.
I thought, oh no.
Yeah, I did too.
Boat people.
Spent my whole life in car audio from before I even had a car, so this has been my passion since I grew up, was growing up. Love everything about it. Can't say enough about this brand, and I love making the amplifiers and the technology that we've been making these last few years.
And immediate to my left, we've got Brandon, one of the new faces on the scene, but someone you're probably going to see a lot in the future. Hint, hint, nudge, nudge, now that you know that.
Well, how you doing, everyone? I'm an integration technician, and I've started here in June, so I've been here about 10 months or so. I have a background in car audio. I was an installer, started at Best Buy. Did that for about 8 years, then went to a mom and pop shop for another couple of years, and I'm very happy to be here. And most of the stuff that I do is testing and validating electronics, and I work in product development for some of the electronics.
Well, I will tell you guys, without these two people right here, Kicker would not be the brand it is. These guys are obviously two of my go-tos and some of the brightest, shiniest faces in the industry. So you're going to see a lot of cool things out of these guys in the near future, and you're going to see a lot of cool things tonight. So, if you guys have any questions, feel free to jump into the chat group, ask any questions you want. I promise if I don't know the answers, I'll make it up. You won't know the difference. It's happened before, and actually somebody occasionally catches me, but no, we'll try to give you the right answers. I'm going to send these two away because we are going to do some LX amplifier testing. So, once you guys go get set up, we're going to kick you off the stage and let you go set up in the room next door because we just don't have enough room to do what we need to in this studio. So, they're going to be kind of not really off-site, but out of the studio in another room in one of our testing labs, our QA testing lab over here. They've got a heck of a setup.
That's right, John.
Yep, sometimes I don't think these things through before I say them. That's what happens on live internet. So, guys, you go get ready, and we're going to take some questions to get started and see what you guys want to see and hear and test, and let's get rolling with this fun little exciting evening. So take it away.
For more than 50 years, Kicker has been rocking the planet on anything that moves. Kicker, the legacy continues.
Kicker Performance Audio. For almost 50 years, we've been rocking the planet with our world-class product covering everything that drives you, whether in your car, truck, boat, motorcycle, side-by-side, or even on your head. Kicker Performance Audio's passion for bringing you your favorite music like you've never heard it before is what drives us. So wherever you need us, Kicker Performance Audio will be there for you.
It's been a long road since the original Kicker christened that first pickup truck. It kicked off a car audio renaissance, and upgrading your music in a vehicle was a requirement. America's music machines became living loud over your passion, your emotion, your existence. Outdoors or on the open road, your sound is Kicker.
For more than 50 years, Kicker has been rocking the planet on anything that moves. Kicker, the legacy continues.
Song looks like.
Test equipment back behind Joe. Real quickly, for those of you that haven't heard much about the LX amplifiers, just a quick little synopsis of them. There's two different heat sink sizes. So you got a small size, and you got the larger size. The full range amplifier, the 500.4, the 1200.5, and the 1300.7 come with this little control center, which gives you all the setup controls for crossover slopes, crossover frequencies. You've got gain adjustments, you've got phase, you've got basically all the setups to make sure that you can tune that amplifier in to sound exactly the way you want. These amplifiers are start-stop compatible down to 6.5 volts. I mean, they're going to have a little less power output, but they're going to stay running clear down to 6.5 volts. Nice thing is with these amplifiers, they do come with the subwoofer level control on the 4 subwoofer amplifiers. That's the 850.1, 1250.1, 1650.1, and of course the 3000.1. It's what Joe's going to test for us in the back in just a little bit. But great amplifiers. You've seen a lot of cool reviews about them. They are really, really impressive. I can't tell you how much I like the way these things work. And in fact, I took the IQ amplifiers out of my car, put the LX in, and I noticed an immediate difference in sound. It was absolutely surprising how much better these amplifiers sound. And I think a lot of it has to do with that much more power. These pack a lot of power in the case. And just remember, all the LX amplifiers, the full range outputs are rated power at 4 ohms. So the 500.4 is 125 per channel at 4 ohms. So with that being said, are we set up back there, Joe? Are you guys ready to show us some cool stuff with the amplifiers? We're going to be testing both with the AP, the Audio Precision, which is the engineering test equipment, and we're going to run them through the amp dyno, so you guys can kind of get an idea what the differences are there. So what do you think, Joe? Are you ready for us?
We're ready. Let's go.
All right, I hear you in the background, so welcome, Joe.
Thank you, sir. Good to be here.
Good. Where's Colin hiding?
I don't know where Colin's hiding. He's probably at home. You know.
All right, Brandon, is he back there?
He runs away. Brandon's here. Yeah, we got Brandon.
All right, so I didn't think you let Colin escape, so just wanted to make sure that you finally let him go home.
No, he finds ways to get out. He's slippery, that one.
All righty, well, tell us what we're going to do, Joe. Let's get rolling with this. I know these guys are excited to see it.
Okay, so today we're going to test 2 different LX amps. The 1205, we are going to test the full range channels, bridge, as that's all the amp dyno can really do is 2 channels at a time, so we want to kind of keep this simple and easy. And then we'll test the sub channel. And then we'll also turn around, we'll do those similar tests, power versus THD sweep on an AP, and we'll also do a power bandwidth on the full range channels so everybody can see what that looks like. SNR as well, we'll show that. And then the second amp, which of course what everybody probably wants to see, is the 3001. So we'll be doing amp dyno on the 3001, we'll even take it down below legal loads. And then we'll do AP testing on it as well once it's nice, warm, and hot. So you guys get to see all of it.
Great. Well, I'm ready to see some exciting action there, Joe.
All right. We'll see if we can catch anything on fire like last time. But here we go.
If you don't break something, it's not as much fun. Because
it definitely isn't. But normally it's not our stuff that I'm breaking. So this time we should be good. All right. So we're going to do
I've been known for breaking a few things in my time, but...
No, not you at all. So this is the sub channel of the 1205. So this is a 5-channel amp, 125 watts by 4 rating, and 700 watts by 1 on the sub at 1 ohm, 550 at 2. So we're going to do the dyno runs at 2 and then 1. We'll even try an illegal one. Then we'll go ahead and we'll switch over real quick to the full range channel, run them, and then we'll switch back to the AP and actually show like THD during the sweep and all that stuff that gives you a little more information than what the dyno can do. So starting out here, we're going to do a certified run. Come on the what? Go back. Oh, we on the, no. Oh, we are on the, sorry, we're doing the 3K first. We got it backwards here. We'll do
Let's go for the big boy first.
Easy enough. We'll go with the big boy first. It's already wired up. So certified dyno run. Mono. Yeah. We know they have to be connected together. We're going to pick our load. No, we'll start out with 2 here.
2 ohm load.
2 ohm load. Enter on track 4. Start dyno. We'll let it go here.
Yep. I don't see any smoke yet, so that's good.
Well, we're set up on outputs on one amp and inputs on another, so hold on. Hard to get good
Isn't
help.
it always fun doing this live?
See if that fixes the issue. There we go.
Yep.
She's live.
Had a nice shot of your ear there, Joe. Thank you for that. And your nose.
Beautiful ear, I know. All right, John, I'm going to need you to write down some numbers here as we go.
I'm ready. 2 ohm power in the 3000 is?
Yeah, 2109.
2109. That's certified, right?
That's certified. 14.42.
Great.
Once again, 2 ohm. We're going to do uncertified.
Still at 2 ohms.
Yep, still at 2 ohms. Get there, you have to go through all these menus. Enter. Here we go, uncertified.
Lots of flashing lights. Holy cow.
2451. Uncertified 2 ohms.
What voltage was that?
1441.
Now, just for a recap there, Joe, what is this amp rated at 2 ohms?
So this amp is rated at 2,000 watts, 2 ohms. And of course, we do a lot of ratings with audio precision at 1%. So
we definitely hit that mark.
Later. I definitely hit that number. Dynamic power run. Yeah. We know we have to have the jumper installed. And off we go. $24.49 at 14.4 even.
So, real quickly, for those that aren't familiar with that dyno, tell them the difference between certified and dynamic power.
So, certified power for the dyno is trying to do 1% rated power. What we've noticed, with that particular piece of equipment, somewhere between 1 and 3.5%. So it gets pretty close. Uncertified is a little bit looser. It's like 1 to 5%. And then dynamic power, of course, you basically play 30 milliseconds of a burst, 90 milliseconds of dead time. I think that's what the dyno does. I know that's what the AP does. And then it sits those bursts that allows your caps to store back up. A lot like when you have, music is dynamic. So you get a bass note, it drops, the cap's charged, bass note drops. So dynamic power is really meant to kind of simulate what you actually get with music. Because up until, 15, 20 years ago, everybody always just tested RMS. And the dynamic number was kind of this, a lot of people used max, which was a made-up number, kind of one of those marketing numbers that didn't really have
brown numbers
to it. Yeah. And then dynamic power always had different ways people would test it. In 2006D from CTA, we finally have an actual standard for the audio precision, and the new audio precision 515, 525 models that came out, they actually can run a standard dynamic test, so we can get reliable, repeatable test results on a dynamic power number now. So that's kind of what we've gone to for the flashy marketing number, because it is applicable and actually matters in the real world, right? With normal music, that's going to be what you can see if your impedance and voltage hold up.
Cool. All right.
So,
want to give another shout out to quick shout out to Andy out there, and guys, don't forget to tune in to Living Loud with Andy right after this. It'll be another good show tonight. He'll be having a lot of fun and kind of a recap, and he'll drift into a couple other subjects, and it'll be good times. So stay tuned for Living Loud with Andy. 1 ohm certified, right?
1 ohm, yep, certified. That's interesting. So when the amp dyno released, it was 3246 right at like 14.4. But when the amp dyno released, the power supply jumped because we got switching power supplies in here to pull all this current to 1568. But yeah, this was 14.4 during the power test. But when we released, it saw the high part and stored it.
What was the power?
3246. Sorry, 1 ohm, 14.4. We will go back and we will do uncertified.
Yeah, tell them about those power supplies. That is quite the bank of power supplies we have there.
Yeah, the power supplies that we have here are something we came up with when we did our first Warhorse amp, the 10K back in the, back about 12 years, 15 years ago now. We needed at least 900 amps of current plus some. Each one of these power supplies is supposed to be capable of 600 amps. We see they're really about 450 amps. And we got three of them stacked together. Yeah. When they make noise, when you draw power from them, I don't know if you guys can hear it in the background, but it's a little intimidating sometimes. They sound like they're getting ready to take off.
Yeah, and these things do not run off 110. Weren't they like 240, three-phase? Yeah.
Three-phase, 240, yeah.
It's pretty serious. We had to have that room specifically wired. And guys, that's why we're doing this testing in that room, because we can't move those power supplies without rewiring the building and getting a permit from the electrical contractor to add a whole bunch more copper. So, all right, let's do 1 ohm, uncertified.
1432, 1334. You get 1435 with 4,137 watts.
How much?
4,137.
Yeah, that's a whole lot of power at 1 ohm.
At 14.
Yeah, if we can get those power supplies to sag, we're pulling some serious current.
Yeah, you're pulling quite a bit when we do this. This amplifier to me is one of the ones that I find to be unique in the size print. There's smaller amps out there that will make similar type of power. I would say not reliably, because for our type of testing, they won't pass it. But this for us is about as compact as we've ever seen, and allows you to have all the power that you can possibly get, and a little better than like a 13 by 8, footprint. So lots of power, small chassis, lots of technology with thermal rollback and other features to keep your music playing all day long, even in the small chassis.
And the fact they'll play down to 6.5 volts.
Yeah,
it's crazy.
Stop compatible. All right, so here we go, dynamic.
This should be good. Not that the others weren't.
4239 at 1439.
That voltage has not changed much at all, has it?
No, these type of power supplies have a feedback leads, and so where we're taking this voltage is still 2 feet from the amplifier because we got a big distribution block. But with that, it allows us to, as long as the signal is enough steady state for us to catch it, right, we can, rectify the voltage. So it starts to drop down, right? They turn the voltage up to match the current, keep it as close as possible. So there's a feedback loop there that happens, just like in our power supplies that we have. Same type of thing happens here on these power supplies to try to keep the voltage where you want it. So I know everybody always loves this. Let's go ahead and do something a little illegal. How about that?
Why not? If you blow it up, you guys can fix it, I'm sure.
Yeah, it's our amplifier.
Hey, Joe, just out of curiosity, what do you think it was pulling for current at that 4,200 watts, just for the viewers?
Somewhere close to 400 amps.
I was going to guess 450.
Yeah, because at full power at 1%, it's almost 300 amps of current. So it's quite a bit. You're pulling a bunch of juice. All right, 0.8.
0.8 ohms. Not recommended, by the way, right?
Not recommended.
I know she's going to do it. Get
4787.
4787. What was the voltage?
1439.
Same as it was at 1 ohm. That is awesome.
Yep. So as you can see, it makes a ton of power in a small chassis. She's warm, right? You put your hand, but she's not that hot, and I can keep my hand on her. They do a great job of getting the thermal out of the chassis. The thermal rollback and some of the other features that we have in there allow a lot of dynamic power to be made, as you've seen, 1,500 watts worth, and keep the music playing as long as you want. Make sure you feed them with good power, though. Good power, good ground. They're going to need it. These are
big 3 upgrade.
Yeah, definitely.
And then
like
some.
John talked about, right? So they will play down to like 6.5 volts. Now, of course, your power goes down with it. So even if you have poor voltage or an install issue with like poor ground, right, this amplifier is going to continue to work. You're just not going to get the power out of it that you could, right? So yeah, please make sure you get the power and the ground right with these, because they make a ton of power.
Yeah, it's like I've always said, it takes power to make power, and we call them accessories, but they really are installation components. Always use good oxygen-free copper, good fusing. I prefer to bolt all my grounds to the frame rather than just screwing it into the frame, put a bolt through it and sand it, and just like I say, do everything you can, give these amplifiers the best opportunity, and they will not disappoint whatsoever. Been 5 years in the making, but oh, so worth it. We're so excited to have them finally, and they are shipping. I think I looked today. I think there's only one model that's in back order right now, if I remember.
The MP2 is already left, so it'll be here in the next couple of weeks to fill that up.
Cool.
Keep going.
So buy all you want. We'll make more.
Yeah, we'll make more. We need a couple minutes to change over to the AP. If you guys can take some questions and let us move some stuff
You betcha.
around, we will get back to it. All right.
All right, guys. So we're going to go live with some questions to see what you guys want to see with this, or any kind of questions you have about the amplifiers, or really anything else. So we got a couple minutes to kill. Like I say, when you're doing this stuff live, all kinds of crazy things can happen. We got a great view of Joe's ear and his nose and the back of his head occasionally, but that's all part of it. It's all part of having fun. And of course, like I say, it's nice to have Brandon up here. You're going to see a lot from Brandon. And these guys really are my go-to guys. If I got questions, if anything isn't making sense to me, I usually go get a hold of these guys or call on any of the 3 of them, and they are going to have the answers that really make sense and exactly what we need to hear. So, all right. So, Bassaholic Productions, thanks for joining in tonight. It says, explain the power bandwidth and why that's so abusive to amplifiers. It's really interesting when you start talking about how amplifiers rated. There's so many different ways to rate things, and so many people bend the rules. Joe's actually going to show you this. I'm not going to go into too much detail right now because I want him to go over it when he actually shows us, because we're going to put these on the AP machine, which the AP is the equipment that we actually design at the acoustic precision computers. So we've got, I think, 15 or 16 of these in the building, and they are not cheap. They're averaging probably $35,000 a piece. But that's one of the reasons why we are never going to have the cheapest amplifiers out there. We spend the money for the test equipment. We do the testing, and you would be surprised how much we spend on blown up gear just to make sure it doesn't blow up when it gets into your hands. But yep, Joe's going to explain that in detail when he can have the graphs to show you real time and explain what all that means. So great question though. So you will get your answer very soon. Next question, what do we got there, JW? Overkill Customs in Tennessee, I'm guessing that is. Why would you run an LX 3001 or a Warhorse 3601 on a Solo X18? Well, the reason you would run that is for power. I mean, if you want to know what the differences are in the two, obviously the 3601 is going to be even more power. That amplifier does certified power, generally about 4,500 watts. It doesn't quite have all the accessories that, all the setup functions that the LX do. The LX are great amplifiers. Obviously, we spend a lot of time designing these. The LX are more of a sound quality amplifier. We really spend a lot of time to make sure they're going to sound phenomenal. Not that the Warhorse don't. The Warhorse is the sledgehammer where, these LX are going to be like the jeweler's hammer. They basically accomplish the same thing, but in different levels and in different ways. But both are incredibly good. And here again, it's going to depend on what impedance you want to run things at. One of the nice things about the Warhorse amplifiers is they've got that competition mode, which basically locks the amplifiers. If you're going to use multiple amplifiers, you can use competition mode. It's going to lock the input voltage to 5 volts. It's going to take out the crossover. It's going to loosen up the regulation on the protection circuit. So if you're using multiple amplifiers and you've got an outboard processor, that's going to be another advantage of the Warhorse amplifiers. The other nice thing about the Warhorse amplifiers are the built-in fans. So those amplifiers have 4 fans built in, and they are variable speed fans, and depending on how much power they're developing and how much power you're pulling in, they are going to vary the speeds of the fans to make sure those amplifiers never shut off. The Warhorse amplifiers also come with that great little display piece, which is going to tell you current voltage, high voltage, low voltage. It'll have a thermal indicator, and it'll have a protection indicator to tell you what type of protection you have. And of course, the LX amplifiers have great protection circuitry built into them too. They've got a protection LED, but they don't go in quite as much detail as that little display on the Warhorse amplifier that will tell you, is it a voltage problem, is it a current problem, or is it a power supply problem? So you'll be able to know at a glance what type of issues you're having. Of course, if it's a current or a voltage problem or short circuit, that's easy to fix. But if it goes into power supply protection, which we haven't seen one do that yet, and all those amplifiers we've sold, then you're probably going to have to get an RA and send that back in. But hopefully you will never see that light. And I've never seen it actually illuminate under actual testing functions, just when we lit it up manually just to make sure the LED worked. So what other good questions we have, Jeremy? Oh, I guess the guys are ready. Guess I talked longer than I thought I did. So we're going to take you right back to Joe and Brandon. So take it away, guys. Let's go back to more testing. What are we doing now, Joe?
All right, so we are taking the 3001 and putting it on the Audio Precision now. First test is going to be power versus THD. It, to me, is one of the most important tests because you're normally not listening to any amplifier, even a stub amp at full volume all the time, right? So traditionally, companies like ours will rate their amplifiers at 1% THD. But most of the time you're listening to them, they're somewhere underneath there, right? So seeing the curve and seeing the floor that the noise sits on gives you a lot better idea of what you're going to hear when you're listening to it, especially on full range amplifiers. But in this case, we're looking at a pretty big monster mono, but same idea applies there if you're doing critical listening. So what
the
we
funny
have
thing
here,
is, I think I called it the acoustic precision a minute ago, not the audio precision. It kind of means the same thing.
Yep. So this is one of their older models. I like to use these because the graphs are a little prettier than the new ones. So for the TV show, it's easier to see it. So we have set up here is we've got input voltage at 100 hertz. We're going to run this test from basically 100 millivolts in all the way up to 6 volts in, and you're going to get a power sweep on the other page. So here we go.
And one of the nice things about the audio precision, you get the graphs versus just a static number. So this is going to be nice to show that power bandwidth.
Good.
When the audio precision works properly.
That wasn't the audio precision. I think that was.
Was that operator error? That's usually me doing that.
Nope, we still got nothing here. Where is
got nothing.
Lead going? Nope.
Hey, I saw it work earlier, so we know it does.
Wrong sense leads. So
that's why I've got you guys doing this, because there's so much going on there. I would never get it straight.
Doing 2 amps at the same night makes it tough, right? If we're just doing 1 amp, it's not quite such a claustrophobic setup. But all right, here we go. So what you'll see is the graph coming across here. As we keep up an input voltage.
And what is that graph showing?
This is power versus THD. So the bottom lines here is your 200 watts, 300 watts, 5, 1K, 2K, 3K, 4K, 5K, 6K. The line going vertical here, that's your THD. So like we normally, like pretty much everybody, anybody that cares about their products will rate them at 1% THD normally. So 1% THD with this amplifier being hot is right about 3,457 watts. Right? And that's how we get our 3,000 watt rating, is from something very similar to this. So we run the amplifier, we look at, but there's things we want to look at when we're designing the amplifiers, right? A good, nice, flat noise floor, as you see here with this line, is important. You'll notice the noise floor jumps here, right? That's when the amplifier switches modes from being synchronized to unsynchronized. You get a little bit of a spike, but you'll notice it's still down around 0.5% of THD. Yeah, this here is where you start hitting the limits of the power supply. So as you hit the wall and you start heading up, that is because your power supply is starting to make more and more noise as you pull from it. And then when you hit the wall, like if we went all the way up to 10-15% THD, you'd see this start to turn and go straight up. So at one point, you hit the power supply where it just can't go anymore, right? It'll go up
So at 1%, we're making 3,457 watts. But at 5%, right, you're making 3,890 watts. And so, like I said, when it's looking at uncertified power on the dyno, it's somewhere between like 4 and 8%, 4 and 10%, depending on the test. And so that's how you get those numbers, because it's running it harder into clipping, basically.
It's still at 5% THD. You're not going to hear that in a subwoofer.
Oh, not
especially
in a
at
sub,
those SPL levels. Good
no.
grief.
Most people set up their subs with 10 dB of overlap or just by the ear. And in most of those cases, you are somewhere near 15 to 20% THD.
I was going to say sometimes 20 to 30, depending on how bad your ears are and just how loud you really want it, and you don't
or if
care.
you just throw it in the trunk, close it, and then turn the gain up in the cab. Yeah, that happens quite a bit. You open the trunk and it sounds terrible, but you close the cab, close the trunk down and you can't hear it. So just keep it going, louder. So tons of power, very low noise floor. Anything under 0.1 is usually considered a really good design on the noise floor. These ones are 0.0 under 3 until they hit over 2,000 watts. Very quiet, very clean. Now we get on to Drew's question.
Yes.
Power bandwidth. Why is power bandwidth so hard on an amplifier? Well, one, because the CTA test that we helped develop actually requires you to do power bandwidth for 60 seconds, right? So here we have this pulled down on the amount of steps we do, but this is still probably 35 seconds here of power. So literally you're just cooking an amplifier into a fixed resistive load, which is about 45% more current draw than a speaker will be, right? So you're pulling more current through the output divisors, you're pulling more current through the power supply, the wire, everything's getting stressed. You won't be able to duplicate this in the field, and that's why a lot of people can get away with running our amplifiers and others at half the impedance they're rated at or less, because in the real world, the speaker doesn't draw as much current as a fixed load does. So these are extreme tests meant to make sure that the amplifier will pass, any real world thing you throw at it in most cases. And so sweeps are one thing. There's a thing called regulation, where you basically, the AP will sit here and jump power up and down until it finds the 1% power number. That takes about 15, 20 seconds. That can be hard on a lot of amplifiers and they'll blow up. But power sweeps are kind of, I want to say the end all be all, unless you run the time sweep like I did a couple appearances ago, where we just let amplifiers cook for like 5 minutes when we were on the show, and that couple of them blew up. But this is about as hard as it gets. So what happens here is it starts at 20 hertz and plays out through the bandwidth of whatever amplifier you're playing. So in this case, it's a sub amp. So we're going to go 20 hertz to 250 hertz, and there's going to be steps that it's going to take. And it's going to change the frequency and look at power versus THD across the bandwidth. And how you rate your amplifiers is basically your bandwidth is when you're down 3 dB. So if you want to say your bandwidth is this to this, and you run this power bandwidth test, and you're actually down 3 dB at 40 hertz, like some amplifiers are, well, technically, if you were going to follow the CTA standard, then you'd have to call your amplifier, a 40 hertz to whatever amplifier, not a 20. Or you have to lower your power down to where that 40 hertz number is at, if you follow that spec. But in this case, we'll let you see how this goes. I think I'm going to go out a little bit farther than 250, because when I did this earlier, you couldn't actually see a 3 dB down on the top. We'll see what happens here. This will also make it a little more brutal.
Yeah. We put our amps to the test here. And there she goes.
So the blue line is basically the power bandwidth, which I started a hair late, so you might have to redo this. The green line is your THD. And so the THD is over here on the right.
The THD is actually going down.
As the frequency goes up, yeah, because the smaller the frequency, the less difficult it is on the power supply to maintain voltage. And so you'll see that. You'll see as the higher frequencies happen, right, the THD goes way down. Let me run that one more time, because we missed the beginning part. We'll cook this amplifier again.
There we go.
There we go.
Yeah, it'll take it. You built them right. Kind of reminds you of one of those old traveling videos where they're showing the plots as the plane's flying from city to city. Boy, that was out of left field.
I can always expect a few of those from you when we get together, John. All right.
Kicker Truck Travis, welcome to the chat.
As you can see, this whole time, this amplifier is making a little over 3,000 watts.
Jeez, that's brutal.
And, so, all right, let me turn this off now that we stopped. Keep cooking it. So this is why power bandwidth is so hard on an amplifier. So with all the steps that are in here, you just saw it takes 30, 45 seconds to even run a subwoofer amp here. So we have this reference to 3,000 watts, so that's the 0 dB mark here. So on the low side, right, we could go down lower and say this is like a 10 hertz amplifier to something if you really wanted. Come up here, so 0 dB is your mark, right, and this crossover is at the highest point right now. So negative 3 dB is going to be right about 140, 160 with the crossover set how it is right now. And that's how you get your power bandwidth. So in this case, right, you would change this from dB to power, which we can.
That's the nice thing about that AP is you've got so much adjustment that you can set up the screens for. And
so here, 3 kilowatts, right, all the way across, and then until you're down. But you can't do dB here, right? So you have to go to the dB screen to actually see where your 3 dB down point is. But you can see where I kept it here. So basically, all the way across this bandwidth, we make what they consider the similar amount of power for this. You can see it does start to go down with power just a hair at the low end because we do have a 10 hertz high pass on these for the subsonic, maybe 15 hertz, but it's outside of the audio band on purpose. But that's why it's so hard, because the time it takes, right? You're just literally cooking the amplifier.
so do I dare make the comment that anything below 10 hertz is wasted information, or do I not say that?
Oh, here, let's see.
That was a joke for Aaron, by the way.
Here's 5 hertz. Let's see what happens. We should see the crossover. No, won't do 5 hertz.
The AP doesn't like it.
Not this
Well,
one.
this is a lot more brutal power test than I remember amplifiers
Oh,
when they
this
rate
is
them
not
at
what we used to
1K
do back
only.
in the day.
Yeah, they'd rate them at 1K. This is your output at 1K. Well, that's not realistic, considering it's like saying, hey, my car gets 43 miles the gallon at 28 miles an hour only. So here we go again. And what is this showing now, Joe?
So we're going down to 10 hertz. Same test. For some reason the graph is skewed.
I was going to say, that looks a little different.
Yeah, for some reason the graph's skewed. Probably good. But you can see down here, like I said, now if you wanted to see your 3 dB down point, right? If we went back to dB over here on this page, and this is why you don't see a lot of people use these in the consumer area, because you have to actually kind of learn how everything works and what the test standards are and go through them. I know Drew has been working on that quite a bit, like trying to get up on all this testing. So at 20, we're still there. 3 dB down is right about 11 hertz. Right? So
That's pretty
hitting into our
impressive.
subsonic filter. So we've cooked this amp to death. We're going to switch back over to the 12 channel. Is there anything else anybody would like to see on this amplifier before we change to something?
Anybody got any quick questions? Anybody want to see anything while Joe's got it all dialed in? Or any questions on the AP product? Oh, thought I saw something there. What do we got there, Jeremy? I'm having troubles reading it on the right here. All right, Kicker Truck Travis says, I know all your amps come overrated. What is the highest overrating an amplifier has come out? And is there a record of one?
Well, if you want to go back to the 90s, you get some 25-watt amps that make almost 1,000 watts back in the day. They weren't particular Kicker branded ones, but I mean, back then, everything in the competition world was rated by rated power, so everybody started lining.
Yeah, 4-ohm power. That would be that HCCA 225.
Those Soundstream Class A 10.0s. Yep. There was a bunch of stuff like that, right? Currently, for
amps.
us, the Warhorse is probably number 1. Some of the LX amps are probably number 2. One one of the things since I've kind of taken over this group has been for me is to make sure that we dramatically overperform in the real world versus what we say we do, right? So as you've seen moving forward, as we get into the newer and newer amplifiers, you're going to see more and more amplifiers from us make quite a bit more real world power or constant power even so than we said it.
Well, and the fact we've gone back to the 4 ohm power rating, I mean, almost
Yeah,
all
for the
your
multi-channel amps,
coaxes out there are
huge.
4 ohms, so.
Yeah, that
But
always
they still
seemed
play
weird
down to 2
me.
ohms very well.
Yeah, I mean, I know we were following what was going on in the industry, but to me that was always kind of weird. Because to me, multi-channel amps, if you're running, you know, a 4-channel, 90% of the time it's 4 ohm speakers. There might be, you know, a 10% install factor where somebody's running 2 pairs, or you got some stock Bose speakers or some JBL Club speakers that are 3 ohms, or whatever the case may be, right? But most of the time, what you really care about is 4 ohm power. And so you'll see that our newer amplifiers, as they come out, started with the PX amp. We rate them at 125. They're really like 175 watts a channel on those little power sports amps to make a ton of power.
We need to have a show on dynoing those amps too.
Yeah,
real quick, I know Mark's got a question here. THD at different ohm loads, question mark.
At max power, it's always the same because they're rated at 1%. On the floor, as you call it, it'll always be the same in the lower level. It will raise some when you saw that like first hump, it'll raise some there. But really it doesn't raise because the only thing you're really doing is pulling more current. So it's not until the power supply gets stressed that actually affects the output of the amplifier. What you do happen with lower impedance is, of course, you create more heat, which over time the heat amplifier gets hotter. Your SNR will go down a little bit. Some components might get slightly farther out of spec because they have a bell tolerance over temperature for the component. And so as the thing starts to move left, as it starts to get hotter or colder, right, their value might drift a little. And as the value drifts, you'll start to see a little bit maybe more THD, in some cases less. That doesn't happen very often. You might see crossovers drift a little bit if they're not doing a DSP. So if the analog crossover and the caps get hot, it might move 5 or 6 hertz one way or the other. Stuff like that can happen with lower impedance loads. Things that people argue, like dampening factor goes down, but as I've talked about, that's not real something that you can hear and work with. So that's not something I really want to get into. The biggest disadvantage is you make more heat, you draw more current. So if you have enough power at 2 ohms, use it at 2 ohms. If you need to use it at 1 ohm, right, and you need that extra power, then you're fine, as long as the amplifier is designed to do it. Most of the time with impedance rise of the woofer and the box, you're not going to really be at 1 ohm anyways, and that's why some of the SPL guys do what they do, right?
It's a little different world there.
Yeah.
So cool. Is Brandon getting close to getting that other amp dialed in for us?
Brandon hasn't come up to start putting the 1205 on yet. He probably needs to. So let's keep talking. We'll get the 1205 up and running.
Cool.
We'll swap over connections. I'll help him a little bit here.
All righty, it's getting the 821. Ashy Larry, once again, thanks for the hat. I remember when Kip and Hi-Fi Vega had the PXI 100.2 on a 1K sine wave for like an hour and 20 minutes. Rob almost had a heart attack. It didn't even get warm. Yep, that was a fun one. So death match, pretty much. But yeah, those PX amplifiers were extremely efficient, and that's kind of the key with amplifiers. The higher the efficiency, the more it's able to convert the power coming in to music, and the less is wasted as heat. So that's why you remember back, in the 90s, the amplifiers, 1,000-watt amp was 2 feet long. Now you can put 3,000 watts in an amp that's 12 inches long, and that has to do with the efficiency and the less wasted heat. The other thing that means for you is you don't need as big of an electrical system in your vehicle, so you can get higher power systems in cars with smaller charging systems. So that's the other advantage of a higher efficiency amplifier. And then it just comes flat out to heat. We've back the bank of resistors that they're using down there. I'm not sure if they've got the amps hooked up to it now, but when we test the original Warhorse, there's 15,000 watts of resistors, and they look like cylinders that are about this tall and about that big around. And I think there's 16 of them there. But good grief, you get that thing fired up at full power, and they put off a ton of heat. So if you think about it, just like anywhere else, you've got a kitchen, and you're trying to keep it air conditioned, you got the grill going all the time. It does make a difference. So, great question. All right, Wade Hensley, are there any shared parts between the CXA and the LX amplifiers? I'm going to leave that one to Joe and Brandon, if they heard the question. I think we got them tuned out there. Generally, it's obviously the heat sinks are different, the controls are going to be different. I'm not sure as far as the outputs, the transistors, the capacitors, any of the other components. I haven't dug into it that deep, but I would imagine that we're always looking for better and better equipment to build the products with, and the LX have been designed for quite a while. That CX amplifier is a hell of an amplifier line. We've sold well over 500,000 of those amplifiers, and we're still talking at under 1% defective rate, even at 500,000 amps sold. So that's pretty impressive, and all that's due to the testing that these guys do. So ADD-24 says, what's the dampening factor on the new LX 3001? Once again, Joe just mentioned that that's another of those buzzwords that you really can't hear the difference in. I don't have that information in front of me. These amps are so new, I haven't seen that yet. Joe or Brandon may possibly have. We can ask them. But once again,
John, can you hear me?
Yep, I can hear you now, Joe.
All right.
Did you hear any of the questions I was asking?
I did. The first one, shared parts. Not too many, right? Like Class D controllers are pretty much, there's only supposed to really 3 or 4 of them. So you'll see shared Class D controllers between the lines. Maybe some op amps and maybe some caps and resistors because there's some housekeeping type parts that get tossed through stuff. But in general, no, they're completely different designs. Right? The layouts are different, the design is different, the goal is different, the feature set's different. These all have a DSP in them doing the crossovers and stuff, whereas the CX, of course, is all analog. So you'll get some housekeeping parts the same, but usually the heart and the brains of the amplifiers will be completely different.
Yeah, and that's why we're a company that we specifically design amplifiers for their use. We don't just change the heat sink and put a different model number of it and call it a different amplifier. They are completely different animals, with like I say, few small exceptions in some of the smaller parts, but they're purposely designed to do what they do.
We go so far as to do things like retool connectors, right? Sometimes, we might get a little too caught up in things, we want it perfect, but you got an hot gauge connector that takes hot gauge ground and power and remote in, and we have probably 10 different tools for them at this point, right? Because they're always maximized for the design of that application. Whatever the footprint needs, so even the way they solder to the PCBs is different between amplifier lines, depending on how we're trying to lay something out and how we're trying to get current out of it. There's a lot of little details that go into these that is, especially in the higher end amplifiers, that kind of gets lost in translation a lot of times. We don't talk about. Dampening factor, my favorite concept.
I knew you'd like that one.
So I grew up as a Robert Zeff person, right? Arc Audio,
Zapco.
Before that, Zapco, before that, a few other brands that he mingled in. And that was one of the things that they always pushed because home audio always pushed. The problem with that idea is back then, most of those were A amps or AB amps or tube amplifiers. The dampening factor is a direct result of output resistance. So if you have a higher resistance output, i.e. your amplifier is less efficient, your dampening factor will be higher. I've actually seen amplifiers where you do the math and you measure them, the dampening factor will be negative, but the amplifiers sound great. The reason dampening factor doesn't really matter in the use case of car audio is because we're playing into 4 or 2 or 1 ohm speakers. And depending on the impedance, dampening factor is all math. And what it comes down to is in the end, so if your speakers are 4 ohm driver, well, that 4 ohms of resistance is what, when the amplifier lets go of control, the stiffness, the back EMF, and all the things of the speaker are what determines how fast it comes back to rest. Well, if you have, say, 1,000 dampening amplifier, and you do the math out, it ends up being like 40001 now is your resistance of your speaker. So you have 0.0001 more of impedance there to break the amplifier a little better. There's a whole long post on it. There's 10 or 12 of them. Andy from Audio Frog posts probably 3 times a year I post 3 or 4 times a year with the math showing why this doesn't matter. Unfortunately, it's one of those things that's been marketed a lot in our industry and in pro audio, home audio, a lot of places as to why an amplifier sounds better than another. But it's not one of the factors. Things more like playing a tritone and seeing what your harmonics look like and how big your harmonics are. That's more important. The THD sweep and seeing where the THD is in the lower or low noise floor, especially on a full range amplifier, because if you have a 100-watt amplifier, 85% of the time you're listening to it at 10 to 20 watts with music, right? It's playing. So what really matters is like that lower noise floor and the lower THD there. Signal to noise at 1 watt is important. A lot of people post signal to noise at full power, which is pretty much irrelevant. It gives you a nice big number. There's a lot of ways to skew the data and show similar data. And that's things where I applaud like the CTA standards that we work on with them, trying to get. The problem there is it's just not very well known and it doesn't add a bunch of value for most customers. The testing they require is almost identical to our testing. It's very similar because of course standards are created together. But in the real world, right, I would say you really should be looking for, if they show a single tone or tritone graphs, you can look at harmonics when it's playing full power. Because 1 watt harmonics will always look good. Like when they're making a lot of power, what's that harmonics look like? THD across their frequency sweep, THD versus power, those two are good things. And then reliability, right? So that comes into like power bandwidth tests. Things that we do, like we'll play them for 7-8 minutes into a resistive load to see when they finally will thermal or hit thermal rollback. You'll have amplifiers that we'll play for 30-40 minutes, watching them get into thermal rollback, pull back a little power, watch them come out, put them back into thermal rollback. So this amplifier is played at max power for hours during that day. But we're extreme. Like there's a lot of amplifiers that I test that are not ours that can't even take the power sweep that we do here. They blow up, within 3 or 4 seconds starting the sweep. So it all depends on the design and how you're going to deal with getting the heat out of the amplifier. That's really your biggest enemy in making amplifiers, getting the heat out. And then everything else comes down to layout, parts, the care, sound.
Cool. Well, we got about ready to do another test. We're having a great show. It's going to go a little bit longer than an hour tonight. So hang with us, people. We got a lot of exciting things. Don't forget the giveaway coming up.
Sorry, guys. It's my fault. Put me to John, and we're always going to go over.
Now, we have too much fun with this stuff. That's not a fault.
So this is the 1205, and the reason I wanted to show this is because this is that backbone workhorse. Throw it in your system. It's the only amp you buy type of amplifier, and a lot of people buy 5 channels still today.
1 amp
They're
fits
one of our
all.
better selling amplifiers. What'd you say, John?
Almost 1 amp fits all.
Yeah, 1 amp fits all type of application, right? So as John said, these are rated at 4 ohms, and of course we rate them. You had 125 watts by 4 at 4 ohms, 175 watts by 4 at 2, and then bridged we rate them at 350. So because the amp dyno once again can only do 2 input, we have this amplifier bridged on the stereo channels, and then the sub is over here on the side going to our new version of that load that John was talking about. Our Warhorse load, we now have a new version of it that is nice and silver on a rolling cart. It's
That's
very
right,
pretty.
with the lab grade resistors. I forgot about that one.
It has the lab grade resistors now, so they stay really within tolerance. And we have big old knife switches to switch from 2 to 1, 4 type of thing.
Frankenstein.
So we can do whatever we want with it, like the old Frankenstein thing. So here we're going to do 4 ohms on the dyno first. This is going to be certified.
Good shot of the power supplies there, too.
Mm-hmm.
Here we go.
So rated at 350 watts, we got 534 on one channel and 520 on the other at 1442.
Yeah, that's pretty good. Was that 40% more power than rated?
Yep, these things are tough. So
that's impressive.
We're gonna do uncertified next. Back there. Yeah, so if you want to know what 4 ohm stereo power will be, divide each channel by 2. That will get you your stereo power.
So 280, roughly? 60, 70?
On the dyno, yes. Not what I would
that's
call it on the AP, but
Yeah, that's crazy.
4-ohm load again.
That's crazy good. And what are we doing now?
Dyno. This is uncertified. About 534, 522, 14.4.
So pretty consistent.
Pretty consistent, yep. Last one we'll do is dynamic. I've never done these tests on this amp before. Brandon might have, but I have not. So I'm
So
a
we're
little.
all learning.
This is all new for me. Yep. Yeah. This, like I said, the dyno. Okay. The dyno is not my typical test equipment, right? So.
Yeah, I know you're usually on the AP.
Yep. Enter. Start
You're
dyno.
good at
All right,
operating that, though.
Getting there. Four. Did I?
We run out of power?
Yeah, I had the track 2, you said? See what happens. Yeah, I had the volume down one step. Brandon scolded me. All right, so 577 and 583 at 14.38.
So almost 600 watts. Dynamic power, bridged at 4 ohms by 2.
Yep.
That's
so
a ton
tons
of
of power on your full range. I pity the speakers that we're going to be running with these in the future. They make a ton of good.
Hey, mine are. That's what I'm doing to mine.
I know. You're probably bridging them too, aren't you?
Yes, I actually have them bridged on the mids.
Why does that not surprise me? Okay, so now we're going to switch over real quick and do the subwoofer. Give us one. This won't take very long. We need to swap a couple loads here real quick. Brandon's going to load the front channels to 4 ohms, so they're still loaded, so we're not cheating. That's one thing with Amp Dyno videos. If they don't have extra loads, you're not pulling all the current through the power supply, so you get bigger numbers than you really should.
And we definitely can't see through you, Joe. So
yeah, so we're trying to make sure that we're doing everything the way that we need to, right? All right, subs loaded to the AP or to the Amp Dyno. All the other channels are loaded to a 4 ohm load.
So everything's loaded down the way it's supposed to. So which is another true test of an amplifier's power. Can the power supply actually do it?
Anybody want to see 4 ohm? I don't think anybody should really run a sub at 4 ohm. But hey, if you guys want to see it, we can. John, thought?
Yeah, let's just go right to 2 ohms. We're going to go a little long tonight, so.
All right. Track 4, right? Yep. All right. 627 watts at 14.4.
And that's at 2 ohms?
That's at 2 ohms.
So that's rated power at 2 ohms when it's rated to do it at 1 ohm. So that's pretty impressive. Now let's run it where it's supposed to.
We'll do uncertified power here next. 2 ohms.
So 2 ohms, it's got more power than we rated at 1 ohm. That's pretty darn good. These are really impressive amplifiers.
Well, the sub's rated at 700 at 1 ohm. Not quite, real close.
Okay.
$684. Uncertified.
Maybe I didn't hear. Are you running 1 ohm now? I'm sorry, I didn't hear.
No, this is still 2.
That's still 2 ohms. Okay.
Yeah, still 2 ohm. Dynamic power. Track 1. Thank you. Brandon's the one that normally uses this thing. 2 ohm load. Dynamic. Track. I'm back.
There we go.
There we go. Looks like 680, 690, 690, 1448.
Nice.
Okay, we will now do 1 ohm.
I'm going to bet it'll make rated power.
Nah.
And we're off.
Power. Whoop. 961 watts.
So 50% more than rated.
At 14.4.
That's... I like it. More power, more gooder.
More power, more gooder. That's how I look at it. We'll do uncertified and dynamic, and then we'll do an illegal load real quick, and then we'll run this over to the AP to finish out. Everybody can get on to what's next for their life tonight. Here. Yeah. Uncertified. Ooh, 4-digit.
There we are.
1241 at 14.34.
Wow.
So it even dropped the voltage a little on us that one.
That, I knew I was impressed. Like I say, I've got those in my car, and yeah, it's...
Yeah, they got a lot of power.
Big step above. I mean, obviously, the
Dynamic
IQ
one.
are incredible amplifiers, but had nowhere near that power, even in the same size package.
So here's the dynamic test. $11.38, 48, $11.48 and 14.36.
That's almost double.
So we'll go ahead and do one heat test here at 0.88 or 0.8. What happens?
Really put the screws to it.
$13.87.
Jeez.
How's that for a multi-channel sub-channel?
That's actually more power than the entire amp is rated.
Well, you know, I've always
So
been a fan of 5 channels with big power when growing up, right? In the 90s, first they were surfboard size. And so when we came into this line, you know, the whole goal was to make a 5-channel that could really take care of a whole daily system and actually, you know, make you happy.
Yeah.
Because I'm a little bit of a bass head, as you know, right?
Yeah,
I like
that's
bass.
plenty of power for a pair of 10s or 12s.
Yep. We're going to move over to the AP real quick. So power bandwidth,
All right.
power sleep.
Well, while you
give us
guys
a
are
minute.
setting that up, Ernie, do you want to like break tradition here a little bit? Let's do the fails to take up a little time so we don't run too late. All right. So let's go ahead and do that. If you want to pull up my laptop there, Ernie, we'll start in with the fails. Guess what's wrong with this picture? Anybody got a guess? I don't understand why I don't have any bass anymore. Yeah, use the wrong screws, that's it. Yep, use the wrong dampening material. But yep, occasionally the surrounds do go by the wayside. And unfortunately, that may not be anything that the user did. Mother Nature does take her toll on various materials. So that obviously is not going to sound very good. Next one. Well, you don't have a car stereo. Well, let's just take our little desktop boom box and let's put the electronics in the middle of the dash. I can't even imagine what it took to cut the dash out to fit that in there, but apparently there's no more heating and air conditioning controls. But if you're willing to do that, you don't care about personal comfort, I guess anyway. Did it get hot? Let's see, the powder coating's blistering on the top of that amplifier, and the charred amp rack behind it should give you a good indication that this amplifier was run a little bit beyond its rated power for a rated amount of time. So I don't even know what brand that is, but I've never seen one get quite that hot before. Apparently it did not have thermal rollback or any type of thermal protection. Here's another fun one. Let's see if I could zoom in on this a little bit. You know, we always talk about, you know, safe routing of the power wire. Well, the real only advantage to what they did here is the power wire is not going to be pinched by the weather stripping in the door, but you still have jagged metal where that wire is going through the bare metal without grommets. So that is a fail on several levels. So, yep, that was definitely an ugly deal. I don't know why it just bounced back past that, but here we are. That's a wonderful mess. So how about this for a laser hair trimmer? What do we got? 8, 9 tweeters on each pillar. I sure hope those aren't piezo tweeters, because you're going to be like driving bugs away. Well, maybe that was the point, you know, to drive away small rodents and insects with high frequencies. That would do it. Christian D. Shadow, I'm telling you guys, my 1307 is very nice. Well, thank you. You've got one of the new ones, a few when they're out. I've listened to it with an external DSP, then use kickers, and to my high level, both ways, very nice. Well, thank you, Christian, for that update. Yeah, I really like those amplifiers. And the other advantage of that 1307 is the other 2 channels, which are 65 by 2 at 4 ohms, and you can bridge those to 130 by 1 for a center channel. That's the purpose of that amplifier. All righty, next one. This is not car audio. This is actually a home electrical panel, but we're still talking about fails in wiring. You know, if you guys saw this video, and I actually saw the video, there was actually smoke coming out of that panel at the time, and the owner of the house actually said, yeah, that's normal. It does that all the time. So it's like, yep, put the fire department on high notice. And kind of keep them with that tradition. Yeah, what a great way to wire up an extension cord. That's not why they put those little holes in the end of the AC plugs to wrap wire around it. Definitely not very safe there. And to go along with that, that's one side of that wire. There's the other side. You see it coming in. What a mess. So it doesn't matter if you're doing home wiring or car wiring. Clean wiring is always safer. It's always going to give you better results. And, you know, if anybody else has to come back in there and service it, it saves them a whole lot of time and effort, because, you know, it's just, who wants to trace down a rat's nest? Who wants to try to untangle a bowl of spaghetti? I know I don't. At that point, I just cut the wires off and throw a match in the house and walk away and burn it down. So, I think I was just notified by Ernie back there that Brandon and Joe are all ready to put that 1205 on the AP, the Audio Precision, and we're going to see what it actually does at an engineering level.
Welcome back, everybody. This first test is like the other one. It's power versus THD, so as the graph goes across, you'll see the THD line and, of course, the power line across the bottom, so you can look at the power. We're going to go ahead and run this now. This is a stereo sweep, so you're going to see one channel. They power both channels at the same time, but they can only look at one channel at a time when they're doing a power versus THD. So you'll see one channel grow first, and then the second channel come along. Once again, this takes a little bit, a little abusive on an amplifier.
Yeah, they don't seem to mind the abuse. Well engineered.
Starts out at 0.02. Goes down
at
to
0.02.
0.004.
That's 0.004%.
Mm-hmm.
If you can hear that, you can hear paint dry and grass grow, as Ernie would say. I can hear the stars moving. Here comes your second channel.
Mm-hmm. Second channel will always kind of have more than the first, because we're making this amplifier very hot. We talked about that before. Yeah. When it gets into the power, that power supply starts to sag. That's when you see the THD start to go up. And we're running this amp, these sweeps into about 12% THD before we stop. So if you look at this currently, right, this is once again forum bridge. They hit 1% at about 358.05, and this amplifier currently is, yeah, nice and warm. We'll just call it that, toasty after everything we did earlier. When it's cold, it'll make more power, like all amps do, but this is after you've been running it for 4 hours, this is what you're going to see. About 358 power watts at 1%. THD floor, this is what I would almost call a perfect amplifier design when it comes to power versus THD. It should always come in low here. Some of the what we would call cheaper amplifiers will start up at like 5-10% and then drop, and they'll normally drop down to like right under 1 and kind of come across here. it takes a lot of time, effort, and actually some money to get your THD4 down. It's layout, it's components, all the stuff goes together to make this happen. They come across, they stay low. In fact, the more power you make, they go lower and lower and lower until you actually start making the power supply get stressed, a little over 100 watts, and it starts to rise to about 0.02, runs across at 0.03, basically until it hits the wall. And so this wall you see here is why I call this like almost a perfect amplifier design. If you didn't have the little hump here from the power supply, this would be perfect. You'd go straight across and you basically hit this wall. You can make a perfect amplifier. It is very, very difficult to do, especially in a multi-channel. The more channels you have, the more stuff in a small enclosure, the harder this becomes. But this is about as close as you're going to get in something that's small. So it comes across.
Especially when you look at the price point of these amplifiers and the power, to have that low of a distortion spec, that is extremely impressive. There's no reason anyone should ever doubt using these amplifiers for an SQ amplifier. They just proved it to you with the graphs and the charts that they are really, really well designed and really well put together, and they pack a punch. What's our next test, Joe?
So this is a very simple test. This literally just looks at signal versus noise. For this amplifier on the full range channel, we rate everything right around 75. This thing's really hot. It's sitting at 75.4 right now at 1 watt. Quite often on marketing material, what you'll see is rated power SNR. In this case, bridge, that would be like 41.16 volts here. And you would see that the actual SNR is like 101 at that power rate. We don't traditionally, we give that number as well, but that's not the number we like to use. It's always the 1 watt, or in this case 2 volts, because that equals 1 watt to 4 ohm
consistency
power number, right? This is how we like to get that. So I wanted you guys to see that. That's how that's done on the older APs. On the newer APs, there's actually a chart over here that happens and a percentage along with a graph you can put up. But these ones are much simpler SNR test. All right, on to everybody's favorite, power bandwidth test.
This is on the 1205.
So this
just
is the
in
4
case you
inch
just
channels. Bridge. This should be all set up already, so nice and hot. We're gonna go ahead and go. Looks like.
Let her rip. What are we off the chart there, Joe?
Too much voltage, it's too hot. Yep. I have to pull back voltage a little bit. See this the way we need to see. Meanwhile, this always leaves the output on. So your amplifier just sits here and cooks while you're on this panel. One thing I don't like. It's too hot. Do a little bit of power. Most people do a 1 watt test of this when they do power bandwidth. That's what traditionally required in the past. And at 1 watt, almost everything always looks flat. When you start to pull current from them, that they become.
That's when you get the real load on them.
You get the real load on them, you start to see where it's hurt.
Well, that looks pretty impressive.
All right, so that is about 200 watts, 240 watts of power. So if we're talking about power bandwidth again, we look at 30 dB down. We're sitting at 2, -2, so you want to be -5. So that's right about 17 hertz. And 30 dB down on the top, you don't actually get there, but it'd probably be about 30K. So this almost could be a high-res amplifier if we wanted to.
Yep, that's impressive.
I'm kind of curious, because the high-res spec, as ridiculous as it is,
isn't that up to 50K?
It's 30 dB down at 40 kilos. So I need to make sure the bandwidth filter is outside of it. That is 10. Oh, it would help if I
looks impressive from here.
Let's see. -30 is. Nope, we don't get there. So we got output filter cap set at like 25, 22 kilohertz. So you have to move those out to get there. So yep, no high res out of it. But there you go. Power bandwidth, THD all the way up to 20K, very low. You see how THD raises when it hits the crossover?
And you said that's at 200 watts too, right?
It is at 257 watts.
Okay, God, that is really impressive.
Yeah. So nice and flat. And pretty much all we got left is the sub channel of this thing. So we're going to switch a couple leads real quick.
Power that thing up, and then we'll move on to, we got a couple of questions, a couple installs of the week, and then we got a giveaway to do. Any questions while we got just a minute while they're hooking that up? All right, Stu's Custom Shop. How you doing, Stu? Any plans to add features to the LX amplifiers via firmware updates in the future? How do they say that? We'll consider that. You never know. Anything's possible at this point. So we're always looking to improve the products. Any way we can do that effectively and affordably, we're going to do it. So don't rule that out, but I can't confirm nor deny. So wouldn't I make a great politician? So another question. Christian D. Shadow again says, then can you explain the triple Darlington output, or was that just marketing? I'm going to let Joe get into that a little bit deeper if he's got just a moment, but it's not just marketing. It is actually a circuit style of how the amplifier is designed and built. So I don't know the exact details on it. I just know the basics of triple Darlington. But Joe, can you answer that question? Are you still with us?
Go ahead.
He's more the engineer. I'm more the tech trainer guy. So I'm going to throw that question at him.
It's very similar. Good old Soundgate, or not Soundgate, Soundstream, triple Darlington power supply. Some other people used it. Our IQ amps actually used a multi-phase power supply in some of them. And basically what you're doing, instead of just having a push-pull, right, so you have one FET driving positive, one FET driving negative, you break your design into 3 phases. So instead of having one phase go high, one phase go low, you now have one phase that goes high, one phase that controls the middle, and another phase that controls the low. The intended advantage of that is less pumping, although when you have a full bridge amplifier, you have very little pumping. But a lot of amplifiers back then were half bridge, and so the power supply would pump a lot. So what that allowed it to do is to break that pumping into 3 stages. It allows you to use more caps, but less of a size of cap. So that's like if you looked at the Soundstream amps or like that, they'd have the whole bank down the middle of them in most cases of cap, but they weren't like huge caps. If you opened up like an old Power 300 Fosgate, it'd have these big 290,000 microfarad monsters in them. It's just a different power supply design. Just like you can have a half bridge amp or a full bridge amp, or you can have a Class A amp or a Class AB or B amp. It's all just different designs and different ways to do something. But that one,
and you can have good and bad in those designs too.
Yeah, there's advantages and disadvantages to every last design, right? That's the thing about electronics, and to be honest, all audio in general. It's all physics, and physics can be bent, but you can't really break it, right? So you can get a little advantage over here by doing this, but then the drawbacks to it are this. But can you live with them? All right, well then,
give and take.
Yeah, you give and take on everything, and that's why it's almost like you're making a soup or a gumbo, or take your choice. You're throwing these different things in because you're trying to get the best results out of that particular design. So it depends on what your goal is. I loved those old Soundstream amps, the triple Darlington power supplies. They had a tendency to, when the output stage got shorter, go boom, but that is okay. That's just kind of one of the things that happens when you have stuff that cross conduct. But they were great amplifiers. It's a neat design. It's kind of like some of the stuff today we don't talk about, like Class A, Class G. Those are all Class D amplifiers, but normally that's them controlling the power supply some way. We do some of that. We don't even talk about it in our key product, where we literally look at the signal coming in and adjust the voltage rails of the key amplifier before the signal even gets amplified and goes out the other side. That's typically what you think of as like a Class G design, but ours is a little different. We're not real big, and a lot of times in using nomenclature on our stuff, which is probably maybe a negative. Maybe we need to get better at that. But it really comes down to just different ways to do stuff. Dampening factor is just a rating. It's not a way to design something. If you want a higher dampening factor, roll some speaker wire up in a circle and zip strap it up, hide it in your car somewhere, your dampening factor will go up because you make it like a little ducting string with the wire, right? You know, a lot of times on those type of amplifiers that had really high dampening factor, we put big bus bars on the outputs of them to add a bunch of copper and a bunch of radiating area, and that would help get the rated number go up. But for power supplies, there's a bunch of different designs. You know, the whole Brazilian half bridge, full bridge argument, unfortunately, has been colored because of some full bridge designs that are not made to what we consider probably, you know, up to our type of spec or our type of standard. We've been making both full bridge and half bridge designs since the 90s, right?
Just depends on the application.
Yeah, it depends on how you build it and the application and your requirements for it. So it really comes down to what you like, what fits in the location. For me, I had other amplifiers in my truck, all tended to, it's usually a test bed for us, but now it's got two 504s, a 1651, all stuffed behind the seat of the Chevy, right? So not a ton of room back there, but I have a ton of power because the 1651 makes over 2,000 watts. So I got a ton of power back there. I could actually fit a 3,000, but I have no need for it at this point. But to get that kind of power, I got 8 channels of 100 some watts, and then a big sub channel all hidden behind the seat, never gets hot, never shuts off. It's a really nice solution for a lot of these newer vehicles. I know we had a question about Warhorse versus LX. To me, it's like your daily driver, ground and pound, LX. If you're doing an SPL rig, buy the Warhorse. Yeah, that's pretty much it. All right, let's move on.
Christian says thank you.
Yep.
So let's go to some dyno tests on that sub channel. And
all right, so this is AP power versus THD on the sub. We'll kick the outputs on, and we'll go
on the LX 1205.
0.0, 2.5 to 0.05. Currently THD. I've got the reference wrong. 3 or 2 or 1.
Almost looked like that ramp up went backwards in time.
Yeah, I need to adjust the table. Is that long enough? All right.
It's like Vegas. You got to adjust the tables.
Yeah. So we only have one channel here, so the second sweep sees nothing. Now this is what I would call a perfect amplifier. So if you look at this, starts
really
out
nice.
0.05, it goes down to almost 0.0, 2.5, stays flat all the way along there, basically until you ram into the wall. Right? And as you ram into the wall, you said here, it actually looks like it goes back. It does. Some of the circuitry I have in here is designed to make you make a lot of power at 2 ohms while still making a ton of power at 1. This is a 1 ohm sweep, so when the current gets really big at the end, we pull it back a little bit. So you're talking
nice.
700 and zoom out. We're talking 725 to right at 1%, 737 with the AP, and that's how now you can see how we get our numbers. But obviously, the dyno numbers you saw were what 900 and some. John,
right.
You have those numbers?
Yeah.
So this is how we get our number there, right? Nice clean sweep, plenty of power, nice and low THD. Power bandwidth we'll do real quick, and then I don't have anything else for you guys unless you want me to try to blow something else up. But these ones are going to be very hard to blow up.
Got some questions we got to get to, and I think we're going to give some stuff away. We're running a little long in the tooth here. We're in about an hour and a half. But hey, it's very good information, and looks like we haven't really lost anybody. So either you guys fell asleep and didn't sign out, or you're still with us. So thanks for hanging on. Because this is a lot of fun. I wish we could do this all the time. Look at me. I say wish we could do it. I'm sitting here just watching the screen. You're doing all the work. All right, Bassaholic Productions. The Warhorse 3600 is one of the top 5 amps released in the last 10 years for subwoofer performance, hands down. Thank you for that opinion. We tend to agree. It is You know, and it's not just an SPL amp. Those things really sound good. I mean, as you can see, every product we make is designed to sound good and have extreme performance, and not to mention durability. Plus, you know, some great features on those Warhorse amplifiers, as we talked about, that little display, the protection that's built into it, the competition mode. All righty.
So this is about 800 watts. That's a little bit into the THD floors. You see the THD start going up when we hit the higher frequencies. It's starting to get a roll off a little bit here.
Andy, I didn't get a chance to read your question, but we'll reach out to me later and we'll find out.
So as you can see here, full 800 watts of power all the way until you start getting the crossover. 3 dB down because we're sitting at +5. And right about here, about 140. And you roll down your crossover to 6 dB crossover. This is like the tri-leak. So you normally read it at 6 dB down. To about 160. So you can see, once again, power bandwidth, nice and flat, good power, low THD.
I bet you that amp's getting warm.
Oh, the amp's nuclear, at least it was. Yeah, can't keep your hand on it. Nice and warm. Nice and warm. That's really all I have to show you today. Unless some people have questions, we'll be happy to answer them.
Well,
bulletproof amplifiers, tons of power, guys. I can't find anything wrong with them. The smaller monos, the 1650 down, all have tons of headroom, so feel free to, you know, put them on something a little bit bigger than you think they should. They got tons of power. You're fine.
Yes, they do. I want to thank you and Brandon for staying with us tonight, running all these tests. Like I say, this is absolutely invaluable information. It definitely proves that, you know, we spend the time in the engineering and the design and the components to make sure our products do exactly what they say they're going to do and more. And a lot of these tests that you saw tonight, you don't see other manufacturers doing it all. I mean, I don't think I've seen anyone ever put, you know, an amplifier on an AP live like this. So, and it is live. We never know what's going to happen.
It is live. You never know what's going to happen. That one time when the competitor amp that was hidden behind the box blew up, had to go put it out. You know, you never know what's going to happen. I will say all of our new amplifiers have what's called white pages on the website. If you haven't downloaded one, you should. It's all the information you really want to know about an amp.
Yep, go to the specifications and
yeah, you'll see a thing that says white page. Click it. It's going to give you the graphs, the power graphs, the crossover graphs, THD versus frequency graphs. So you'll have like a 1K rated power tone and the harmonics around it, so you can see what it really does. That type of stuff. Lots of information there, way more than I think anybody gives you. So take a look at it.
Got nothing to hide here.
Yep.
Cool. Well, thank you guys. I really appreciate it. I know while you guys are tearing that down, we're going to go, like I said, we got a couple of questions we're just going to hit, and then we're going to go ahead and jump right into the giveaway. And we got a couple other quick things to talk about. But thank you guys for doing that. And stay tuned after we're done. You guys don't leave, because I think we want to get together, if possible, for an adult beverage. I think you guys have earned it. So I think I have, too, because I've sat here and put up with this all night. But anyway. So just a couple little things. We got events coming up. Master Tech is coming up in Phoenix from March 20th to 23rd. That is this weekend. I will be leaving tomorrow morning. I know a bunch of my friends in the industry are already out there. Master Tech is a great place to learn new skills and learn from the best people in the business and some of the most advanced equipment out there and designs and procedures. So if you have never been to Master Tech, it is well worth it. Also, while you're at Masters Tech, Skills USA has a table set up. Brian is going to be out there, and he's got a table. If you want to learn more about Skills USA, you know, Aaron talks about that quite a bit, and Jacob. It's a great place to find some younger new help, and hey, if you're just hands-on, you want to learn more, Skills USA, they do everything from nursing to carpentry, electrical, audio. I mean, you name it, they probably got classes on it. So skillsusa.com. It's a great way to build some new skills. Don't forget, the flat track racing is starting. It's getting warm, so look for Lauren out there. He's going to be in Senosa, Georgia for the start of the flat track racing. I will also be at the Man Show April 4th and 5th in Springfield, Missouri at the Ozark Fairgrounds. I will have the Mustang there if you guys can get out. come by and check it out for the LX amplifiers. We took the Q class out to put these in, and man, I'm glad I did. If you're curious what the Man Show is, I mean, it's a little bit anything having to do with things guys like. There's a car show, they've got drifting, manufacturer booths, there's beer, there's bourbon, barbecue, sporting goods, all types of man cave events, home improvement, so it really is a lot of fun, and that's going to be at the Ozark Fairgrounds. And don't forget Living Loud with Andy tonight. Don't forget that. He's going to have a great show, as he always does. And then May 17th, right here at Kicker, if we got the logo, if you guys can pull that up quick, we will be having a SQ event here at the Kicker National Headquarters. Feel free to come out for that, register to participate, or just come out and enjoy. All the big name people are going to be here, all of our good friends in the industry, and it's going to be a really good time. And no, this is not going to be anything that's biased towards Kicker products. It's just going to be a whole lot of fun. And like I say, we really hope you guys can make it out for that and to see this beautiful facility that you do not get to see enough of through the camera. So great. So that's what's coming up in the near future. Let's roll on to a couple questions here real quick before we give things away. First question I got is, why are there two power inputs and grounds on the Warhorse amplifier, and why are there two speaker outputs? Is this two mono amps and one heatsink? No, as we talked about, this is a single channel amplifier. With that much current draw, you really need to run two power in and two power out. And yes, it is mandatory you use both of those inputs and outputs, because the power supply and the design of the circuitry is balanced that way. It's going to perform much better, and you're going to be less likely to have any failures. And the reason there are two speaker outputs is so you can connect two speakers in parallel much easier than trying to twist the wires together or crimp them. That's just a convenience feature for you guys. That's why we put two of the speaker connectors on several of our mono amplifiers. All right, so moving on to a Solo X question. You only list one ported box for the Solo X woofers on your website. Is this the only box they'll work in? Well, this is one of those questions I love, because people always, hey, will this speaker work in this box? My answer every time is yes, it will work in any application. The question is how well, and will be suited for your needs. So far, those woofers are so new. We've been working so hard to get the products out, and with the amplifiers, we haven't done a whole lot of actual in-house building of demo boxes and testing. We made sure we got one that was kind of, going to really perform really well. And here again, with the TL Smalls, and all that is on the website now. Once again, if you go to the specifications, you can download all the TL Smalls for their woofers. And if you put those into a program, you can design any type of box you want. I had someone ask me a while ago for a bandpass box for the Solo X woofers. And, we don't have anything we recommend, because quite frankly, you can probably get better performance out of a ported box, and it's going to be smaller and be a lot less complicated to build. But if you want to build a bandpass for them, if you've got a lot of these good subwoofer design programs out there, plug in the parameters and you should be pretty pleased. That woofer is designed really well and really accurate TL Smalls. And hey, an LX question, it's kind of funny since we're on that subject. Can you use the LX remote control at the same time as the base level control? And the answer is no. They actually have two different set of operating codes. So even though they use the same cable, you cannot run them both at the same time. There is a switch that you can get, which is basically it's a RJ45, 2 in and 1 out, so you could literally put both controls and connect it to the amplifier, but you would actually have to manually select one or the other. In fact, we've got the display that's up here. I'm going to be adding those switches to that display for our on-the-road training. Second question is, can you shut off the LEDs on the base level control? And yes, you can. They are pretty bright, and if they're too bright, a double tap on the base control will shut off the LEDs when it's not in use. As soon as you turn that dial, it's going to pop right back up to show you the level. So great questions, guys. If there's more things you want to see, or if you have any questions on the LX amplifiers or anything else in the Kicker line, just remember support@kicker.com. We got 4 guys upstairs that do a really good job of getting back to you. If you send them a question in, one evening, they're usually, going to get back in touch with you the very next day. And if it's during the day, they usually will have an answer for you before the end of the day. So great place to get questions answered. And now I suppose, since we're about 42 minutes past our projected show ending time, which thank you guys for hanging out, it's time to give some things away. So hopefully JW back there is ready to give me some names. So if you would mind, if you guys have all registered, once again, every time we do this, it's KICKER/UM Weekly. That's how you register for the competitions. And also at MasterTech, while you're there, and you can still, I believe you can register online, correct me if I'm wrong, but if you go to kicker.com/giveaway, we're going to give away a subscription, a full unlocked subscription to True RTA, which is a 2-channel oscilloscope, a 24th dB per octave RTA program. It is really nice. In fact, that's the one I use. In fact, you've seen me use it on the show before. So we'll be giving one of those away at MasterTech, and you can register online for that as well. So, all right. JW, who is the third place winner, which is going to win the EB400s, the t-shirt, and the koozie? That is going to be Jessica M. from Ohio. Congratulations, Jessica, and thanks for tuning in tonight. Watch for an email. I think Colin will send you an email. We're going to need your name, your address, your phone number, and it has to be an actual shipping address, not a P.O. box. And, of course, we'll need to know your shirt size. Nothing personal, but we want to get the right size shirt for you. And if it's not for you, let us know what size of, whoever you're going to give it to, what size they wear. So, second prize winner is Jason W. from Texas. Jason, you're going to win the TW2, the in-ear earbuds, the true wireless earbuds. Once again, I love those. You'll get the t-shirt and the koozie. And here again, watch for that email. I believe it's going to come from Colin, and he'll ask you for that information so we can get your winning shipped out to you. Number one grand prize for the evening is going to go out to E. Kimball from Illinois. Congratulations, you're going to win that little Bluetooth speaker, that BF100. It's a great sounding little Bluetooth speaker, and that is 100% waterproof. I've actually thrown them out in the surf in Cancun when we were at one of our company events and let it roll around in the water for about an hour playing music. It was actually kind of fun, kind of cool. Guys, I know we went really long tonight. Thank you guys for all tuning in. Once again, we really appreciate all your support. Appreciate you guys, sticking with us, and any input you guys want to give us, things you like, things you don't like, things you need, things you don't need, please let us know, because we've been in business for 52 years. The only reason we've been able to do that is we do listen to what you guys say. So thanks for tuning in. Have a great, safe week. We'll be back again in 2 weeks. Yes, that is April 1st. That is not an April Fool's joke. We will be back on April 1st. If I remember, I think I'm going to be on too. I can't remember. I haven't looked that far in advance, but I think that's another one that I'll be doing with you guys. So I'll be looking forward to that. And if I see you guys in Phoenix this week at MasterTech, be looking forward to it. That's going to be a great event. So hopefully you guys can make that. And above all, be safe. Have a great night. And tune in to Living Loud for Andy. And come back in 2 weeks at the same time, same bat channel. And we'll be having some more fun with Kicker equipment. Thanks again, guys. Have a great night.